Okay, in this section we're going to be looking at 5A and 5B. So that's going to be types of energy, and then we're going to look at two types of energy in a little bit more detail. So the first part of that is 5A, types of energy. So the first thing to think about is what is energy? And energy is the ability to do work. So I know that sounds a little vague, but there's really not a great definition of energy. So for now, we're going to treat it like this. Energy is the ability to do work, um, but you're going to get a better sense of intuitively what it is a little bit later. So energy, right, this ability to do work, it's a scalar, meaning it only has size. It does not have a direction. And it's going to have the standard metric unit of joules. So you're going to see like 5J, which would mean like 5 joules of energy. And there are lots of different types of energy. So this table is actually going to be all the major ones we're going to look at. Depending on what source you look at, you'll see other ones, but these are the main ones we're going to look at. So the first type is kinetic. So that's the energy of motion, but that's only for everyday objects. So when we talk about kinetic in this, at least how we're going to look at it in physics, it's going to be for large things, not so much for atoms or smaller things. So some examples would be pushing a shopping cart, or if you had a rolling ball. So both of those would have some amount of kinetic energy because they're both moving. The next type of energy would be thermal. So that's energy due to temperature. So again, a candle, a heater, right? Both of those give off heat. They both have an elevated temperature. They're both going to have thermal energy. The next one, electrical. That is energy due to the flow of electricity. So examples would be like a light bulb, Xbox, or really any device, any electronic device. So anything that runs on electricity. Suppose this is a light bulb. That's going to have electrical energy. The next type is gravitational potential energy. So that's going to be energy because something's raised to an elevated position. So an example would be like if you had a book on a high shelf, a house on a tall hill, right? Anything where you have an object that's basically raised off of the ground, you're going to have some gravitational potential energy. The next type is electric or elastic potential. That's energy stored in a springy or stretchy object. So an example would be the spring in a Nerf gun, a rubber band. So anything where you can store energy because it's springy because it's stretchy, you'll be able to store elastic potential energy. The next type of energy is electrical potential. This one's a little bit more abstract. So electrical potential is energy stored in an electric field. And we'll talk about exactly what electrical field is later, but it's basically any object that produces this kind of aura, this field around it, electrical field around it, and in that field you can actually store energy. So a lightning storm, that's an example of electrical potential energy. A battery, so they're storing electricity in a field. The next one would be the magnetic potential. So that would be energy stored in a magnetic field. And again, we're going to get into exactly what fields are a little bit later. So again, if you have an object, it's a magnet. Certain objects are going to produce magnetic fields, and you can actually store energy with those. So an example would be like a fridge magnet or an MRI machine. They're going to use magnetism basically to store energy in a magnetic field. And the last one is chemical potential. So you've definitely seen this before. That's going to be energy that's stored in chemical bonds. So basically any really molecule is going to store some type of chemical energy. Like technically even water, right? There's the oxygen, there's the hydrogen. Between the bonds between the atoms, you're going to actually be able to store some energy. So anytime you have a substance where there's a significant amount of energy that you can extract by breaking those chemical bonds, we're going to say it has chemical potential. So food's a good one. There's a lot of chemical potential energy in food. There's also a lot in gasoline, would be another good example. So those would be examples of chemical potential. So in this sheet, or this section of the notes, this is the big idea was these are all the types of energy that we're going to look at. There's lots of different types. Just for now, being able to identify where, when they're present. Realizing that energy for now is a little bit abstract, but we're going to think about it as the ability to do work. So if you could do work, there must be energy of some kind. Energy, that it's a scalar, that it has a unit joules. So that's it for just energy in general for now. Now we're going to look at the next section, which is going to be profiling two types of energy in more detail. Okay, so you see here, in 5B we're going to be looking at specifically kinetic and gravitational potential energy, because these are types of energy that are going to come up a lot. So kinetic energy, right, that's the energy of motion of everyday objects, large things, like if you had a ball moving, it would have some kinetic energy. It's going to have the abbreviation K, uppercase K for kinetic energy, and the formula is right here. So again, it's made out of stuff you've seen before, so it's 1/2 times the m for mass, so the object's mass, and then it's v for velocity squared. And again, just the thing to take into account is there's a squared term here. So because there's a squared term, kinetic energy is always going to be positive. Because even if you can never have a negative mass, and even if you had a negative velocity, it'll be squared. So that's how you can actually calculate kinetic energy. The next type of energy is gravitational potential energy, and it's abbreviated UG. So the U part is for potential or potential energy, and the G part is for the gravitational. Just abbreviate that. And the formula for this is m times g times h. So the m for mass, g for the acceleration due to gravity. I'm not going to write out that whole, I'll just abbreviate accel. So it's a magnitude of acceleration due to gravity. And h is the height above the ground. So h is the height, that's the only new thing is h. That's the height above ground level. So depending on how high something is off the ground, that's going to determine how large that h is. And again, if it's on the ground, right, if you just had something on the ground, this would have an h of 0. So again, if something like this would just have no height above the ground. Okay, so again, these are two equations that we can use to calculate energy for two different, or they're equations we can use for calculating two very common types of energy, kinetic and gravitational potential. So the last part, we're going to do a problem out. So an example. Here we go. So again, make sure you pause it and you attempt it first. Again, you're not on Tumblr, blogging, or something. You're attempting it. Okay, so we'll get into the problem. So we have a book of a known mass. It's moving across frictionless ice at 5 meters per second on the top of a hill that is 1,000 meters tall. So we'll just draw it out actually quickly first. So moving, it doesn't say it's falling off, but it's moving on frictionless ice on some elevation on the top of a mountain. So this is the scenario. So what type of energy does it have? It's going to have, there's lots of ones you could kind of argue maybe, but the most obvious ones are kinetic, and I'm just going to abbreviate that K because it's moving, and gravitational potential because it's raised off of the ground, basically. There's some height above the ground. So those are the two big types of energy. You could technically argue other ones, but these are the ones that you're most concerned with. B, what's the total energy of the block? Total energy, that's just adding up all the different types of energy. So that's going to be in this case, it's just going to be the kinetic plus the gravitational potential, because those are the only two major types. And this is going to be equal to, actually draw it one level down. This is going to be equal to just plugging in the formulas. So kinetic is 1/2 the mass times velocity squared. The potential is mgh. So what we have here is, we're just really going to plug in once we get here, because we know the mass, we know the velocity, we know g, we know h. So once you get to here, it's really just plug in. So you get 1/2 the mass, which is 0.1 kilograms, times 0.1 kilograms times, what is it? What's the velocity? 5 meters per second squared, plus the mass again, times g. Little g on Earth is 9.8 meters per second squared, times the height, 1,000 meters. We're going to get out the total energy. That's going to be 981.25 joules. J for joules. So that's the total energy. That's just the energy of all the different types of energy present combined. Okay, so that's the problem. That's a good example of something you'd see in the future. And that's it for now.